Hey everybody, Mr. Beckstrom here, and I had a couple of questions in the forum, so I thought I would go over them. All right, the first one was from section 5.2, and it said sketch the angle -135 degrees in standard position and find its reference angle in degrees and radians. So let's go ahead and do that one first. So I'm just going to do a rough graph, and I think it gave you choices in there, so we just really kind of need to know what quadrant it's in. So positive angles, we always start at the positive right axis, x-axis here, and if we're doing positive angles, we go around this way. So this would be 90, 180, 270, 360, and then you just keep adding 90. So 450, another 90 would be 540, that would be 630, 720, and you just keep going around that way. Now, if you start over here at 0 and you go the other direction, which would be clockwise, then you would go negative. So that would be -90, -180, -270, -360. So when we're trying to find -135, that's going to be between -90, which is down here, and -180. So -135 is going to be right dead in the middle of, because if you look, let's pull up my calculator here, and I were to say, what, -135 plus 180. Looks like it's 45 away from 180, and if I were to do -135 plus 90, and it's also 45 away from 90 as well. So it's going to be right dead in the middle there. Right dead in the middle. So that angle is going to look just like this. So it's going to be in the third quadrant. So we also have to know our quadrants, right? Make sure I get that. So that's our third quadrant. So just to review, let me make that a little bit better here. So 1, 2, 3. So that's our third quadrant. This is our fourth quadrant. This is our first quadrant here. And this is our second quadrant there. All right, so 135 degrees is right about here. This is also in radians, so we also need to know how to convert it, which I did a video previously. So if you take a look at resources, you'll find that video. So to convert it, I do 135 degrees. I am having a hard time with the mouse. 35 degrees times, remember, I want the degrees on the bottom of my unit fraction, so times pi over 180 degrees. It's converting it over. And this is going to be equal to 135 pi over 180. And remember, I showed you all how to do the shortcut to find out how to find the fraction in reduced form without doing that prime factorization. I can just do 135 divided by 180 to get a decimal. And then I just do math, frac, enter, and that's 3/4. So this is going to be 3 pi over 4. And remember, this is a negative here, which I should have put in the beginning. So this is going to be a -3 pi over 4. So this is going to be my radians here. And that should be a negative there as well. All right, so this is the answer for the first one, number 6. Now let's go ahead and do the second one. The second one says find the exact value of sine of alpha given that the cosine of alpha is equal to -2/9 and alpha is in quadrant 2. Now there's a couple of different ways to do this. Now, if you go to question help in there, it's going to do it in one way, which is a completely valid way, but I like to do it another way. And the reason I like to do it the other way is because you can actually find all the trig functions pretty easily doing it the other way. So first, let me show you the way that they do it. And they're going to use the Pythagorean identity, and that's this. It is that sine squared of x plus cosine squared of x is always equal to 1. And what this means that if you take a sine of an angle and you square it, and you add the cosine of an angle squared, that's always going to give you the value of 1. No matter what angle of sine you square, and no matter what angle of cosine that you square, you're always going to get 1. And by knowing this, you can figure out what a sine of an angle is given a cosine of an angle. So how do you use that? Well, since they give you the cosine of an angle, you can say this. You can say the sine squared of x plus, and we know the cosine of a is equal to -2/9. So I can just write this as -2/9 squared. Remember, the cosine squared of x is the same thing as the cosine of x quantity squared. So I can just replace the cosine of x with -2/9 is equal to 1. And now I can just kind of solve for that. So this is, I'm going to do it two different ways here. So the sine squared of x is equal to 1 minus, because I'm going to square this thing and then subtract it from both sides. So this is -2/9 times -2/9 is going to be 4/81. And then I'm going to subtract that from both sides. I'm going to get 1 minus 4/81. So it's going to look something like this. So now sine squared of x is equal to, that's going to be 81/81, because that's, I'm going to write 1 as 81/81 minus 4/81. So 81 minus 4 is 77. So this is going to end up being 77/81. And then I'm going to take the square root of both sides. So the sine of x is equal to plus or minus the square root of 77 all over 81. Now this is equal to, now we are in the, which quadrant are we in? It says we are in quadrant 2. So we're in quadrant 2. And in quadrant 2, which is up here, we're trying to find the sine. The sine is related to the y values, and the y values here are positive. So we can ignore the negative solution there. So we're only looking at the positive values. So this is going to be the square root of 77 all over 9. Right? And that should be your answer right there. All right, and so you don't need to look at the negative, because we want a positive answer only, because we're looking at the sine, and the sine is our y values, related to our y values. We're in the second quadrant, that's why they tell us that, and in the second quadrant our sine is positive. Now let me tell you the way that I would have done this. I would have done this by making a triangle. I would have said, well, let me erase this one right here. I like triangles. I don't know. It's just me. All right. So because you can get all 6 of your trig functions really easily by doing this. So if I'm in the second quadrant, I will draw, it doesn't matter how I draw my line, but I just draw a line coming out from the origin up in the second quadrant. I draw a line down, making a right triangle with the x-axis, just like this. So I have a triangle that looks like this, right? Just like this. Now, this is my angle. I always draw the angle coming out from the origin. And looking back, all right. So it gives me that the cosine is 2 over 9. Now, if you remember from SOHCAHTOA, let's write that down. So SOHCAHTOA, that's SOHCAHTOA. So SOHCAHTOA stands for the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So this is the cosine. So the cosine is adjacent. So that's the adjacent side over the hypotenuse, which is the longest side, which is the side opposite our right angle. So the adjacent side would be 2 over the hypotenuse, which would be 9. So I'm going to write this as 2. Oh, let me put it back on pen. The adjacent side to the angle from the origin over the hypotenuse, which would be the longest side, the side opposite my right angle here. And once I do that, I can easily find my last side just by using the Pythagorean theorem, right? So what? A squared plus B squared is equal to C squared, right? Where C is the hypotenuse. This is one of my legs, and this is my third leg, right? So I'm going to get that B squared is equal to 9 squared, which is 81, minus, 81 minus this, minus 4. So B squared is equal to 77. And so B, taking the square root of both sides, B is equal to the square root of 77. So now I have all 3 sides of my triangle. And here is my acute angle, my angle that I'm talking about. So now I can do all of my trig functions really easily. So they already gave me my cosine, which is adjacent over hypotenuse, which is 2 over 9, and I'm in the second quadrant, so I know it's negative. My sine is opposite over hypotenuse, SOHCAHTOA, opposite over hypotenuse, and it's positive because I'm in the second quadrant, so that's square root of 77 over 9, which I found out the hard way using the Pythagorean identity down here. My tangent, if I needed to know that, would be opposite over adjacent, so that would be square root of 77 over 2. And then I could also find out my cosecant, my secant, and my cotangent just by reversing those, right? My cosecant is hypotenuse over opposite, my secant is hypotenuse over adjacent, and my cotangent is adjacent over opposite. So once I set up my triangle, just by finding that third side, then I can actually find all 6 of my trig functions really easily. And it's not much more work than just using that Pythagorean identity. All right, I hope this all helps, and if you have any questions, let me know, and I hope you have a great rest of your week.